All right, guys. So we are going to be going over unit rates and ratios. So we can go ahead and just call this unit rates. And again, you should be copying this down into your math journal. Unit rates and ratios. Okay? Unit rates and ratios. And unit rates and ratios, this is really going to tie directly in with lesson 7. Okay? So it's going to tie into lesson 7. Lesson 7 is all about unit rates. And so the first thing I kind of want to do is define some terms here. And one of those terms is unit rate, because it's obviously an important part of what we're discussing here. So the unit rate equals the ratio displayed as a fraction, okay, in simplest form. So what does that mean? Anybody want to tell me? Anybody who's dared to master this material already? And I'm actually going to make this a little bit bigger. Can everybody see what I'm doing? No? It's not projecting? Nobody can see. Sweet. That's awesome. Thanks, Google Meets. You're the best. And it's to make it as small as possible. So simple form, let's check that out. If we have 5/10, the simple form of 5/10, can anybody type that in or shout it out? Oh, people are definitely talking and I cannot hear them. Sorry, guys. The simple form of that would be 1/2. Okay, so 1/2 would be the simple form. And we would be able to get that by just doing what we already know how to do. What we do to the top, we do to the bottom. What we do to the bottom, we do to the top. Okay, so that would give us the simple form. 5/10 is 1/2. Or if you're talking ratios and you're saying 5 to 10, okay, then the simple form would be 1 to 2. Okay? So what does that mean when it says the ratio displayed as a fraction? What does that mean, the ratio displayed as a fraction? Well, that means, just like what we see here, if we have a ratio of 5 to 10, then the unit rate, and let's do unit rate in green, the unit rate would equal 1 over 2. Okay? Because all you do is flip the fraction, or excuse me, flip the ratio, so that it looks like that. And then simple form would be 1/2. And that would be your unit rate. Okay? So this, this is the unit rate for 5 to 10. Okay? So this probably doesn't make a ton of sense on its own because there's nothing really attached to it. However, if we said for every 5 hours that goes by, there is 10 gallons of milk produced by a dairy. I don't know why I thought of that. That's just what I thought of. Okay. So if we're looking at this, now we are bringing some context in. So if we say that for every 5 hours that goes by, there's 10 gallons of milk produced by a dairy, we need to find the unit rate for that. The unit rate would be, we'll do our same thing where we get our ratios and we underline them. The descriptions, okay? And we'll circle the amounts. And then we'll go ahead and write hours, okay, to what's on the other side of this ratio? Hours to what, guys? You can type it in because I don't think I can hear anybody. Somebody type it in. What do we got on the other side of this? Gallons. Thank you, Jesus. So we have gallons on this side, and that can be abbreviated as H to G. And then we just plug in our numbers. We have 5 to what? 5 to what? What do we plug in for G? Perfect. Thank you, Jesus. And you're right. I cannot hear you. So if you keep unmuting and talking, I do apologize, but I cannot hear anything that you're saying. So now we have 5 to 10. And now we want to see this become a unit rate. So the first process is we have to flip this so that it becomes a fraction. So we just literally take this, right? And we take this. I try to use this tool, by the way, to show people where I'm getting these numbers from. I hope this makes sense, because a lot of times I remember when I struggled in math, I would just never understand where these numbers were coming from. And then this thing right here actually becomes a fraction line. And I'm going to show you something. This is why I like this lesson the most. I'm going to show you something that will hopefully blow your mind. Now, are we done? Is this the unit rate just like it is? Yes or no? Is this the complete unit rate? If we're looking at our definition of what a unit rate is this our unit rate? No. Eric says no. Jesus says no. Annabelle says no. And I agree with you guys. But can anybody tell me why? Oh, Jesus has an answer. We must reduce this to simplest form, right? And we know that we can get anything to become 1 by dividing it by itself. And we just so happen that 10 is divisible by 5, so we can do this to the top and to the bottom. So if I do that to the top, I am going to come out with 1. And if I do the same thing that I did to the top to the bottom, I should come up with 2. And this is still, I don't want you guys to think this has changed. This is still hours to gallons. And let's just get the gallons from right over here, just so this is still hour to gallons. Okay, so nothing has changed. We still have hours to gallons. And so that unit rate would be 1 to 2. Okay, so 1 out for every 1 hour, there's 2 gallons that's pumped out. Okay, and that is how you should display the unit rates. Now, there's something really cool about unit rates, ratios, and fractions that I want to share with you now. And I'm kind of going to put a little line here to separate off. Not that it's completely separate, but I want to show you guys something. As you know, ratios we use the word to, which is the same as the colons, right? And in fractions, we use the word over, and that's equal to this line, right? Everybody following so far? Perfect. Now this is where it's just like mind blow. This is going to be a mind blow right here. So the deal, okay, the last thing I'm going to put down here is division, okay? And we have different words for division. We have over, we can use as well. We have per, or we have divided out. Okay, these are all different ways that we can say or indicate that we need to use the operation of division. The symbol for division can be this. It can also be this. And some people see the division house. So there's lots of different symbols. What I want to show you, though, is I want to erase this. I'm erasing it because what I want to show you blew my mind, and hopefully it blows yours. So there is a serious relationship between ratios, fractions, and divisions. Division. If you remember from last year, okay, we interpret fractions as a division problem. So really 1 over 2 is equal to 1 divided by 2, which is equal to, how many times does 2 go into 1? Well, 2 can't go into 1, so it goes in 0 times. So it goes in, I said 0 times. But we're not done. We put the decimal, right? We bring that decimal up. We add that 0 in. How many times does 2 go into 10? 2 goes into 10 5 times. And that equals 10, which means 0. And 0.5, as we know, is equal to 5/10, which is equal to 1/2. It's all very circular, like a recycle symbol, right? Check this out, guys. Maybe you've seen this before. Maybe I'm not showing you anything you don't already know, but check this out. We take the ratio symbol. Did you guys see that? I took the ratio symbol. Now I'm taking the fraction symbol. What symbol does that create? What symbol did I just create using the ratio symbol and the fraction symbol?